Okay, I hope I'm audible to all students who are attending this lecture of intermediate macroeconomics. In this particular lecture, we intend to look at some numerical problems based on Solow model. Okay, so these are some of the numerical problems on the Solow model, which we have covered theoretically in our lectures in intermediate macroeconomics. So let's look at the first problem. Suppose the production function for the economy is given by y is equal to k to the power alpha, al to the power 1 minus alpha, where y denotes the output, alpha, which lies between 0 and 1, okay, denotes the share of capital and the share of effective labor in producing the output. A denotes the technological progress, which grows at the rate g. The labor grows at the rate n, and capital evolves according to this equation. So S into Y denotes the savings, D denotes the rate of depreciation, DK denotes the rate of capital, the amount of capital which has been depreciated. So we need to, the question is asking us to express the production function in terms of output per effective unit of labor. So given the production function, we first need to convert this in terms of per effective unit of labor, and then we need to derive the steady state for this model. Okay, and then towards the end, we also need to argue that the output per capita must be growing at the rate. So let me now come to the whiteboard. Let me write the equations and let's start working this problem. Okay, so question number 1, what is given to us? I am writing that again for perfect clarity. We are given the production function, which is y is equal to k to the power alpha, al to the power 1 minus alpha, where alpha lies between 0 and 1. Okay, y is the output, L denotes labor, K denotes capital, and A denotes technological progress. And we are given that L increases at the rate N, the labor population grows at the rate N, A, which is technological progress, increases at the rate G, and the capital accumulation equation, or the change in the capital stock, is equal to the new capital added, which is savings minus depreciation. So this part denotes savings, this part denotes depreciation. Now, first of all, let's convert the production function in per effective worker terms. So first of all, if A denotes technological progress and L denotes the labor, then the point to understand is that A into L denotes effective labor. A into L denotes the effective labor. So how do I convert my production function in per effective labor terms? So consider the production function y is equal to k to the power alpha, al to the power 1 minus alpha. Dividing both sides by al, I get y by al is equal to k to the power alpha, al to the power 1 minus alpha over al. I have just divided both sides by effective labor. Now y by al I can call as y tilde is equal to k to the power alpha and al to the power 1 minus alpha. The base is the same. I can subtract the powers. I can write al to the power, this is 1. So 1 minus alpha. I'm writing a note here that x to the power m over x to the power n, I can write as 1 over x to the power n minus n. These are certain properties of power functions. So similarly, al to the power 1 minus alpha divided by al, I can write 1 over al to the power 1 minus 1 minus alpha. So y tilde is equal to k to the power alpha over al. 1 minus 1 minus alpha will be how much? 1 minus 1 minus alpha will be 1 minus 1 plus alpha, which is alpha. And this I can write as k by al whole to the power alpha. And k by al, I can call it as k tilde. So y tilde is equal to k tilde to the power alpha. So this gives me the production function in per effective worker terms. So if I erase this initial part off now, I can write that therefore y tilde is equal to k tilde to the power alpha, where what is y tilde? It is y by al, which is equal to output per effective labor. And then we have k tilde. If I erase this part off, k tilde is equal to k by al, which is my capital per effective labor. So I hope all students have understood how we have got y tilde and k tilde. Okay, now let's continue towards solving for the steady state, which the question is asking us. So now to solve for the steady state level of capital stock, which equation are we going to choose? Capital per effective labor. Because I want to find the steady state level of capital stock, so I choose capital per effective labor. So let's start with this equation. Now let me erase this particular part. So I can write, consider k tilde equal to k over al. Okay. Now I need to see how k tilde changes over time, because ultimately I need to figure out the steady state for this particular model. So I am going to differentiate both the sides, and before doing that, let me first take logs. Now, why am I taking logs? The reason I'm taking logs is so that I can figure out the growth rate. That is the objective for taking logs. So taking logs on both sides, I can write ln k tilde is equal to ln k by al, which implies ln k tilde is equal to ln k minus ln al. Using properties of logs, ln of x by y is equal to ln x minus ln y. These are properties of logs. And students, ln al I can further write as ln a plus ln l. Again, ln x into y is equal to ln x plus ln y. These are all properties of logarithms. So I can ultimately write, therefore, ln k tilde is going to be ln k minus ln a minus ln l. And now I am differentiating the above equation with respect to time. So I can say differentiating. Why am I doing all this? Why am I taking logs on both sides? The reason is I want to find the growth rate of capital stock per effective labor. To find the growth rate of capital stock per effective labor, I take logs and then I differentiate with respect to time. So differentiating with respect to time, what do I get? So if I erase this initial equation, now which equation am I differentiating? I am differentiating this equation with respect to time. What's the derivative of ln k tilde? 1 over k tilde times the derivative of k tilde with respect to time is dk tilde by dt. Remember, the derivative of ln k tilde is 1 over k tilde times the derivative of k tilde is dk tilde by dt. It's called the chain rule of differentiation. What's the derivative of ln k? 1 over k times what's the derivative of k with respect to time? Dk by dt. Minus what's the derivative of ln a? 1 over a times what's the derivative of a with respect to time? dA by dt. Minus what's the derivative of ln L? 1 over L times what's the derivative of L with respect to time? dL by dt. So I can now write this implies 1 over k tilde times dk tilde by dt is how much? K tilde dot. Whenever I differentiate a variable with respect to time, in short form, I can write that variable with a dot on the top. For example, I'm writing it here. dy by dt, I can write as y dot. So dk tilde by dt, I can write as k tilde dot. Similarly, 1 over k times dk by dt, I can write as k dot. dA by dt, I can write as a dot. dL by dt, I can write as L dot. So what does my equation look like? If I erase the bottom portion, it looks like this. K tilde dot by k tilde is equal to k dot by k minus a dot by a minus L dot by L. Now in the question we are given that a increases at the rate g. So that means we are given that the growth rate of a dot by a is nothing but the growth rate of a. That's what? That's g. L dot by L is nothing but the growth rate of labor force, which is given to us as N, because of the question we are given that labor increases at the rate N. That means A dot by A is equal to G, L dot by L is equal to N. So can I put these values in the equation? If I erase this particular part, so I can write K tilde dot by K tilde, which is this, is equal to K dot by K minus A dot by A, I can write as G, L dot by L, I can write as N. Now guys, what is K tilde? What is K dot? K dot is Sy minus Dk. So can I plug this here? Can I plug this here? Let's see what do we get. Erasing this part off. I can write, so K tilde dot by K tilde is equal to, how much is K dot by K? K dot is nothing but Sy minus Dk over K minus G minus N. So I can say therefore K tilde dot by K tilde is equal to, I can separate, I can write this as Sy by K minus Dk by K minus G minus N. I can write it like this. This implies K tilde dot by K tilde is equal to S Y by K minus K and K cancel here, minus D minus G minus N. If I erase this initial part now, and if I continue with the algebra, I can write K tilde dot by K tilde is equal to S times. Now, if you look at Y by K, students, what can I do? I can divide both numerator and denominator by AL to convert to per effective term. So I can write Y by AL divided by K by AL. Now, why am I doing this? The reason I am dividing the numerator and denominator by AL is so that I can convert into per effective terms. And within this whole expression, I can take a minus common. So I get D plus G plus N. Okay. Now, if I erase this particular part, I can finally write K tilde dot by K tilde is how much? S times Y by AL is Y tilde. K by AL is K tilde minus D plus G plus. So I hope first of all students are clear till here and have no doubts. So now I can multiply K tilde with this whole equation. I can do that. I can multiply K tilde with this whole equation. So I can write K tilde dot is equal to S Y tilde by K tilde minus D plus G plus N whole multiplied by K tilde. I have just taken K tilde to this side. It gets multiplied. Very simple. So if I erase this initial part, I can write K tilde dot is equal to, now Sy tilde, I am opening up the bracket. So Sy tilde by K tilde times K tilde minus D plus G plus N times K tilde. So this expression multiplied by K tilde time minus this expression multiplied by K tilde. Just opening up the brackets. What do we get? If I erase this part off, therefore K tilde dot will be, this and this cancel out, Sy tilde minus D plus G plus N times K tilde. Okay, this is what I get. I hope all students are clear till here, this equation, and have no doubts. So now what we are going to do is, we are going to now solve for the steady state. So I'm erasing the bottom equation. We finally have the equation in front of us called the capital accumulation equation. This equation is also called as capital accumulation equation. It is showing how the capital stock per effective labor is evolving over time. Okay, so I can also write this equation shows how the capital stock per effective labor evolves over time. Okay, now in the steady state, what should happen? In the steady state, I can say that K tilde dot should exactly be equal to 0. This should exactly be equal to 0 because there should be no change in the capital stock per effective labor in the steady state. So this implies that 0, or I can say, what is my k tilde dot? This whole expression. So I can say this implies sy tilde minus d plus g plus n times k tilde should be equal to 0. Remember, this whole expression was k tilde dot equal to 0. Now recall, students, what was y tilde? You must have written it down in your notes before. Recall, y tilde is equal to k tilde to the power alpha. This is what we had got when we had converted output per, when we had converted the production function in per effective worker terms. This is what we had got. Now the time has come to plug this here. We are going to plug back the value of y tilde here. So what do we get? If I erase this part off, let us see what do we get. So S times y tilde is k tilde to the power alpha minus d plus g plus n times k tilde is equal to 0. If I solve this further, what do I get as my k tilde? So it's S k tilde to the power alpha equal to d plus g plus n times k tilde. This is what I get. So I can write, what is my, if I solve this for k tilde now, so I can take this k tilde here and I can take s here. So what do I get? K tilde to the power alpha over k tilde as d plus g plus n over s. I can write it like this. I've just rearranged the terms. Okay. So now, erasing this particular part, let's solve for k tilde. I hope students are clear till here and have no doubts. Then I can further write, if I erase this, if I continue, I can write k tilde to the power alpha over k tilde as k tilde to the power alpha minus 1 is equal to d plus g plus n over s. How did I get this? The base is the same. I can subtract the power. So alpha minus 1. So this implies my k tilde will be d plus g plus n over s whole to the power 1 over alpha minus 1. D plus g plus n over s to the power 1 over alpha minus 1. Or I can have another answer. I can have another answer. So if I erase this particular part off, let me write this answer. K tilde is going to be s. If I switch the numerator and denominator, if I take the denominator on the top, if I take the numerator in the bottom, if I switch it, I can write s over d plus g plus n whole to the power 1 over 1 minus alpha. The sign is going to change. Instead of alpha minus 1, I'll have 1 minus. So this answer is also correct. This answer is also correct. I can label it as star. Why? Because this is called the steady state level of capital stock per effective worker. So I can write this is the steady state capital per, if I erase this part of steady state capital per effective worker. This is what the question was asking me to derive. Okay, so we stop in this particular lecture. The question is not over yet. In the next lecture, we are going to look at how to find y tilde star. Basically, in this lecture, for problem number 1, we have found out the steady state capital for effective worker. In the next lecture, in the next practice lecture, I'm going to work out the value of y tilde star. So I stop in this lecture. I hope all students have enjoyed this lecture. Any doubt, you can mail me at divineschoolof economics@gmail.com. This is where I stop in this lecture.